Question 18. So to find dy dx, so remember how to do this. You multiply by the current power and then reduce the power by 1. So x cubed becomes 3x squared. Moving on to our second term, multiply by the power, so minus 4 times 2 becomes minus 8, and reduce the power by 1, so x squared becomes x, and then plus 4x. When you differentiate that, you get plus 4. Now for part B, work out the coordinates of P, show clear algebraic workings. Now we can see that P is a minimum. The gradient at a minimum or at a maximum is 0. It's horizontal, the gradient, just for a brief second. So we solve the differential being equal to 0. So we're solving 3x squared minus 8x plus 4 equaling 0. Some of you may just be able to do these by sort of trial and error and go straight to this line here, but I prefer a slightly more long-winded method. So I'm looking for two magic numbers that multiply make 12, being the 3 times the 4, yet at the same time add to be the minus 8, and those two numbers are minus 2 and minus 6. So step 1 is to split this middle term into minus 2 and minus 6x. It doesn't matter which way round. I've chosen to split this middle term into minus 6x and minus 2x. So basically at this stage we've gone from a 3-term problem to a 4-term problem by splitting that middle term. You then fully factorize the opening two terms, so 3x, x minus 2, and then fully factorize the third and fourth term, so minus 2, x minus 2. And just make sure that you've got the two brackets being the same. And then our final answer is a pair of brackets comprising what's presently the repeated bracket, the x minus 2, and then the other bracket are the other two bits, so the 3x minus 2. So we've got 3x minus 2, x minus 2 equaling 0. Now we can see that we get two solutions here. Now the minimum is the greater of these two solutions, and we can see that our two solutions would be x being 2/3 or 2. We want the bigger one, so x is 2. Okay, obviously clearly this has got a bigger x value than the maximum. So x is 2. Now what is y when x is 2? Well, we take our 2 value for x and we substitute it back into the original curve. So 2 cubed minus 4 lots of 2 squared plus 4 lots of 2 plus 3. I've done that down here in purple, and we get the y coordinate being 3. Now for part C, write down the range of values of x for which the curve has a negative gradient. So we can see the curve has a negative gradient in this stretch here. Now we've just worked out that our minimum value has an x value of 2. And from this other bracket we can see that the x value of the maximum is 2/3. That's by solving 3x minus 2 equaling 0, x being 2/3. So it's the range of x values within here, so x is less than 2 but greater than 2/3.